given 5x squared is equal to negative 5. So the first thing I did is I added 5 to both sides to get 5x squared plus 5 equals 0. The reason I did that is that we're going to use the quadratic formula, and I want it to be ax squared plus bx plus c is equal to 0. Okay? So now that means that my a term is 5. My b term is the number in front of x, which there isn't one, which is 0. And then my c term is just equal to 5. Now remember, it's a, b, c. The number in front of x squared is a, the number in front of x to the first power is b, and the constant is c. Now to solve this using the quadratic formula, I say that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to negative b, but that my b is 0, plus or minus the square root of 0, or the square root of 0 squared minus 4 times a, but a is 5, times c, but c is also 5. Do all this. Alright, all over 2 times a, but a is 5. So then, if I simplify my work, I get x is equal to, 0 goes away, I've got plus or minus the square root, 0 squared is 0, negative 4 times negative 5 is negative 20, times 5 again is negative 100. I'm just going to double check that to make sure. So I've got negative 4 times 5 times 5. Negative 100. Negative 100. All over 2 times 5, which is 10. The problem is normally you can't take the square root of negative 100. So what we'd like to do is let's rewrite this as the square root of 100 times the square root of negative 1 all over 10. Now the reason I wrote it down that way is because now we are going to have to use what we call imaginary numbers. So complex numbers have a real and imaginary part. So you can have a real number and then you can have an imaginary number. Now the reason we call it imaginary, it's like a placeholder for situations like this. So one thing I know for sure is that if I have a square root of negative 1, which I can never ever 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 have a square root of negative 1 because anytime you square something it's positive. So for example, if I were to say negative 2 squared, that's positive 4 because it's really negative 2 times negative 2. So if I take a negative number and I square it, it will always be a positive number. If I take a positive number and square it, it will always be a positive number. So I cannot square root negative numbers by the very nature of the fact that I can't undo what hasn't been done. In other words, there's never a number that I can square that will give me a negative value. It will always be positive. So whenever I run into this negative 1, I think that must be some value I. We use I because we're imagining that it's something. So then if I come back to my problem here, I can continue my work by saying x is equal to plus or minus the square root of 100, which is actually 10, over 10, and then the square root of 1 is just I, or plus or minus 1I, or just plus or minus I. And that's a good answer. So now what does that mean? Well, we're used to, when we graph something, a quadratic formula. For example, this would be this right here. If you look at the graph of this, the graph would look like this. It'd be symmetrical about the y-axis, but it would have a y-intercept of positive 5. So it would be like this. And that makes sense, right? Because we say that real solutions are zeros. In other words, the real solutions cross the x-axis. So when we talk about zeros, we're talking about where the graph crosses the x-axis. But if you look at my function, it never crosses the x-axis because it has a y-intercept of positive 5. So when I go to solve for a solution, I'm not going to get a real number, so I have to have a placeholder, which is an imaginary or what we call a complex number.